Good afternoon. You are watching EduSet lecture. Friend, as you know, data research involves various phases like data collection, tabulation, data analysis, etc. And data analysis is one of the major area where the researcher have to work. And there are various software available for the data analysis. We have already discussed SPSS and others in the last two lectures. And today we are going to discuss one of the major tools, that is ANOVA, analysis of variance. And for discussion on this very topic, we have in the studio Dr. S.K. Pandey. He teaches at Ford School of Management, New Delhi, and his area of expertise is marketing research. So I think his knowledge and experience will help us to understand this tools, ANOVA, that is ANOVA, in a detail and a new way. So on your behalf, I welcome Dr. Pandey for EduSet lecture. Welcome, sir.
Thank you very much. So good afternoon, everybody. In a series of lectures where statistics is used for research methods, this is the third session in the same series where we will be talking about analysis of variance. Analysis of variance is a very important technique and is used in research, in all types of research, whether it is marketing research, financial research, HR, operations, etc. It's a very widely used technique and is used to compare groups. The plan for today's lecture is that we will first have an overview of analysis of variance. Then we will talk about the relationship between analysis of variance, correlation and regression, and analysis of covariance techniques. Then we will talk about various types of analysis of variance, like one-way analysis of variance, two-way analysis of variance, and also n-ways analysis of variance. Then we will talk about statistics associated with one-way analysis of variance. What are the various statistics and how do we interpret those statistics? Then we will conduct a one-way analysis of variance. We will identify the dependent and independent variables in ANOVA. Then we will decompose the total variation of the dependent variable. Then we will measure the effect of independent variables on the dependent variable. Then we will test the significance, whether the independent variables actually affect the dependent variable or not, and then we will interpret the results and take decisions based on the findings. We will take examples and through the example we will illustrate the various statistics and the decision making based on this. Illustrative application, then we will also deal with what are the various assumptions which we take into account while doing analysis of variance, and in the end we will also talk a little bit about n-way analysis of variance. Analysis of variance is used as a test of means of two or more populations. The null hypothesis typically is that all means are equal. Analysis of variance must have a dependent variable which is metric and either measured on a interval or ratio scale. It also has an independent variable or more than one independent variables. However, all the independent variables must be categorical. That means they should have categories. In these scales we call them nominal variables. So basically in analysis of variance we have two types of variables, one independent variables and the other dependent variable. The dependent variable is usually one only and the independent variables can be more than one. The dependent variable is metric, measured either on an interval or a ratio scale, and the dependent variable is usually non-metric, which is categorical in nature. There must be one or more independent variables, as I said, and categorical independent variables are also called factors. So in analysis of variance, the independent variables are called factors and the dependent variable has to be metric. A particular combination of factor levels or categories is called treatment. In one-way analysis of variance, there is only one independent variable which is categorical, and there is only one dependent variable, which is metric, either measured on an interval scale or measured on a ratio scale. In two or more factors are involved, then it is called, if there are two factors, it is called two-way analysis of variance. If there are n factors similarly, it is called n-way analysis of variance. If the set of independent variables consists of both categorical as well as metric variables, then the technique used is called analysis of covariance. The independent categorical variables still are called as factors, whereas the independent metric variables are called as covariates in this case. So analysis of variance is used where the independent variable or independent variables are only categorical in nature. However, if the independent variables are both categorical and metric, we use analysis of covariance. And the metric independent variables are called as covariates. Now, if you see the relationship between the various analysis of variance, covariance and regression, we find that in all the cases the dependent variable is metric. As I have been repeating, the dependent variable is metric and is measured either on an interval or a ratio scale. However, if the independent variable is binary in nature, that means only two groups are there, then we can have independent sample t-test. Analysis of variance is often considered as an extension of independent sample t-test, which you have already studied in the session 2. So if the independent variable is binary and the metric dependent variable is 1, then we can have independent sample t-test. However, if the metric dependent variable is there but independent variables are all categorical, then we use what is called as analysis of variance. If there is only one independent categorical variable, we call it one-way analysis of variance. If there are more than one, we call it n-way analysis of variance, if there are n independent categorical variables. However, if we look at if there are variables, independent variables which are both categorical in nature as well as they are also metric variables, then it is called analysis of covariance. So ANOVA and UNCOVA, as they are called in the short form, are closely related. In UNCOVA we have some independent variables as, or at least one independent variable as metric variable called as covariate. Then if the metric variable dependent variable is already metric and the independent variable also becomes metric, and or all independent variables are metric, then we can use what is called as regression, correlation and regression. So correlation, regression, analysis of covariance and analysis of variance, these three are closely related, especially depending on the independent variables. If all independents are categorical, we use ANOVA. If some of them are categorical and some of them are metric, we use analysis of covariance. If all of them are metric, then we use correlation or regression. However, in all the three cases, there is only one single metric dependent variable. So based on these three, we use either of these three techniques, either ANOVA, UNCOVA or correlation regression. As I said that analysis of variance or ANOVA is used in many business applications, whether in marketing, finance, HR or operations. Marketing researchers are often interested in examining various things and they use ANOVA extensively. One-way analysis of variance is used when there is only one independent categorical variable having usually more than two categories, because in two categories we can also apply what is called as independent sample t-test. As I already mentioned, ANOVA is kind of an extension of independent sample t-test, and if you understand independent sample t-test, analysis of variance becomes very easy because most of the things are in accordance with independent sample t-test in ANOVA. Now we will take certain examples where analysis of variance can be used. As I mentioned in the very beginning of the lecture, that analysis of variance is often used to compare groups, or more specifically group means. So suppose there is a problem like the marketeer wants to know whether the various segments that we have identified differ among themselves on certain criteria. This criteria must be the dependent variable which is metric in nature. For example, this dependent variable can be the volume consumed. So suppose we want to know whether the undergraduates, graduates and postgraduates, these three categories differ in their consumption of consumption of fast food, then we can apply what is called as analysis of variance. If we want to see the difference in any three groups, we can, and the dependent variable is metric in nature, we can always apply what is called as analysis of variance. Other examples of where analysis of variance can be used in marketing is, suppose we want to know whether the brand evaluation of groups exposed to different commercials vary. Suppose we have made 3 commercials and those 3 commercials are shown to 3 different groups, and then we ask or measure their perception or attitude towards these 3 different advertisements on a scale, that is an interval scale from say 1 to 7 or 1 to 9 or 1 to 10. Then we can find out the mean of the 3 groups and compare whether the 3 group means are equal or not. The hypothesis being that the 3 groups means are equal, or in layman terms, all the 3 advertisements are equally effective. Another problem where ANOVA can be used is, what is the effect of consumers' familiarity with the store on preference for the store? So suppose there are 3 groups, one which is highly familiar with the store, other which is having a medium familiarity with the store, and the third group is having hardly any familiarity with the store. They don't know about the store. And we want to see whether these 3 groups differ in their attitude towards patronizing the store or giving preference to the store. So here again there are 3 groups and we can compare them through analysis of variance, and the preference for the store has to be an interval variable measured on a scale of say 1 to 7 or 1 to 9 or 1 to 5. Although I did not give other examples, but analysis of variance can be used in almost all conceivable branch of management. I'll take some examples from finance and HR field also to make finance and HR students understand the applicability of ANOVA. Suppose we have got 3 different or more than 3 different groups. In finance, these groups can be, suppose I am interested in maximizing my return based on investment in various shares. So suppose the shares can be divided into 3 types. One, say IT industry shares, other may be FMCG industry shares, and the third may be some other sector shares. And these become 3 different types of shares, and I want to see which one of them give better returns, or is any one of them gives different return from the other. The hypothesis here will be that all 3 give equal returns, and then we can apply analysis of variance to see whether the 3 groups differ in their returns. So analysis of variance can be applied equally good in finance. In HR, suppose we have got say 3 groups: lower management of the employees, middle management of the employees, and higher management of the employees, and we want to know whether these 3 groups differ in their attitude towards the organization, or maybe loyalty towards the organization, or anything which can be measured on an interval scale. So if we measure these dependent variable, that is loyalty, perception, attitude, etc., on an interval scale, and then we can apply the analysis of variance because there are three groups, the hypothesis being that all the three groups are similar in their approach, and then we can measure their attitude and see whether there is any difference in the attitude or perception of the three groups. So as I mentioned, that analysis of variance can be used in marketing, HR, finance, or any sort of business situation where we have got an independent variable which is categorical, having groups, and dependent variable has to be metric, either an interval or a ratio scale. Now we come to certain statistics associated with analysis of variance. The first statistic is eta square. Eta square tells the effect of the strength of independent variables on the dependent variable. However, our hypothesis is that the independent variables do not affect the dependent variable, and if the eta square value is very high, which ranges between 0 to 1, 0 means there is no effect of independent variables on the dependent variable. However, if the eta square is equal to 1, it means 100% of the variation of the dependent variable is explained by the independent variables. That means we can predict with 100% accuracy, or we can 100% tell what is going to happen to y if we know what are the independent variables. Then we also test the hypothesis of all means being equal, or in other words, independent variable explains the dependent variable. In this case, the F statistics test the hypothesis that the population null hypothesis that the category means are all equal, that all the groups are equal in their means. If the hypothesis gets rejected, then we will have to believe that at least one of the groups is different, although all the groups may be different from each other, is also a possibility. Mean square, this is the sum of squares divided by the appropriate degrees of freedom. SS between, sum of squares between, it also denoted as SSX. This is the variation in the dependent variable which is related by the means of the categories of X, or simply speaking, this is the variation which is explained by the independent variables. SS within is the difference or the variation in the categories themselves and is not accounted by the independent variable, and SSY is the total variation in the dependent variable. So what are the steps that we need to take in order to conduct a one-way analysis of variance? First, we have to identify the dependent and the independent variables. Like in the previous case of marketing, the three ads or advertisements become independent variables, and the perception or the attitude of consumers based on these three ads becomes the dependent variable. So the first step is identifying the independent variable and the dependent variable, and also ensuring that the independent variable is categorical and the dependent variable is metric, because only then analysis of variance can be applied. Then we decompose the total variation of the dependent variable. So we have to understand the total variation of the dependent variable. We will decompose this total variation of the dependent variable into what is or what can be explained by the independent variables and what cannot be explained by the independent variables. So we decompose the total variation. Then we measure the effect. Basically, measuring the effect means we try to measure whether or which one of the independent variable is different from that of the which of the three groups or more than three groups are different from others. Then we test the significance, whether we are able to explain significantly, and then based on the results we interpret the results and take decisions accordingly. So the total variation in the dependent variable y, which is often denoted as y, can be divided into two parts. This decomposition can be divided into two parts. One is what is called as SS between, and the other is called as SS within. The SS between is the variation between the groups, and the SS within is the variation within the group. The within the group variation is not explained by the categories, because our hypothesis is that the group means are different. So if there is a large SS between and a small SS within, we will be in a position to reject the hypothesis and believe that the groups are really different from each other. However, if the difference between the groups or SS between is lesser and SS within is almost equal to SS between, we won't be in a position to reject the null hypothesis, and we will have to conclude that the groups are not different from each other. Also, SS within is the variation in Y related to the variation within each category of X and is not accounted by X. So it is also referred as SS error. So SS within is referred to SS error, and SS between is also referred to SSX. So this becomes the equation. The total variation SSY is the sum of SSX plus SS error, where SSY is the deviation or the squared deviation of each data from the mean of that entire data set. SSX is the variation of the mean from that particular mean of the group from that of the overall mean, again is squared and multiplied by the number of data points. And SS error is the variation or squared of the variance between the mean of that group and the various entities in that particular group. It will become more clearer from the example that we take. So this is the independent variable, and this table indicates that these are x1, x2, x3 to xc groups. So these many groups are there. Our hypothesis is that all these group means are equal. In these group, in each group there are n observations. So, and if we take all these y1, y2 of various groups and find out their overall mean, that will be considered as the overall mean. However, each group will also have a group mean, which is denoted by y1 bar, y2 bar, y3 bar, and so on. And all the if we take the mean of all the means also, that will also become the group mean. So group mean can be calculated in two ways, which is denoted by y bar here. Either we calculate individual means and from there we find the overall mean, or else we can add all the various y's and find out the group mean. Eta square statistics is given by SSX upon SSY. So SSX is what is explained by the difference between the groups, and SSY is the overall. So in a way it can be said how much is the variance between the group explained by the model that we have chosen. Now, conducting one-way analysis of variance. In one-way analysis of variance, the interest lies in testing the null hypothesis that all group means are equal, or all category means are equal, which is also equal to the population mean. So our hypothesis becomes that mu1, mu2, mu3 all are equal, and it equals the population mean. So these are the statistics. F statistics is given by SSX upon C minus 1 degrees of freedom, and SS error upon N minus C degrees of freedom, which is also called as mean Sx and mean sum of errors. This statistics follows the F distribution, and based on the F distribution we can find out whether the hypothesis got accepted or rejected by the degrees of freedom. If the null hypothesis of equal means is not rejected, then we don't need to go any further, and it gives it says that our null hypothesis stands true in this case. However, if the null hypothesis got rejected, then there can be various possibilities. For example, suppose in the HR example that we took, we wanted to know whether the perception of the lower management, the middle management and the top management differs about the organization. Now in such a scenario, suppose we take these three groups and compare their perception on a interval scale, and in the end the hypothesis gets rejected. If the hypothesis gets rejected, it means at least one group is different from the other groups, but there can be various possibilities. For example, the lower management may be different in their perception as compared to the upper management and middle management. The middle management can be different from the upper management and lower management. The third case can be that the upper management is different from middle and lower, and middle and lower do not differ from each other. Or else there can also be a scenario where all three groups are different. The lower management has a different perception than the middle management, and the middle management is also different from the upper management as well as the lower management. So if the hypothesis gets rejected, there are various possibilities that can take place. So for knowing those possibilities, or for knowing the right possibility, we need to go further and do what is called as post hoc analysis. So post hoc analysis is done when the hypothesis gets rejected. However, if the hypothesis in this case does not get rejected, then we have to conclude that all three groups are same in their perception and there is no difference between the groups so far as the perception towards the organization goes. So in such a scenario, we don't need to do any post hoc analysis because all three group means are same. But if all three group means are not same, then we need to find out which one is different and whether all of them are different, or what are the various permutation combination and what is the actual seen in this case. A comparison of the category mean values will indicate the nature of the effect of the independent variable in analysis of variance. Now we will take an illustration of analysis of variance. We will illustrate the concept discussed in this chapter using a table called as table 16.2. This example has been taken from the book of Naresh Malhotra, Marketing Research, and it appears in the chapter number 16, and the table is 16.2. The departmental store, I'll give a background of this problem. The department store is attempting to determine, so there is a departmental store and they want to know whether the in-store promotion affects sales. Usually if you go to departmental stores or malls or any of these organized retailing outlets, you will often find that they will be doing some sort of a promotion. At times the promotion results, is of the nature that you get one free from every purchase, or you get some kind of a price discounts, or at times you may get some other benefits, coupons, etc. So in-store promotions are basically there. You will also find that often there will be some kind of an announcement going on when you are in a departmental store or in organized retailing, and the announcement will often tell you that if you do this thing, then you are going to you can benefit in this manner, and so on and so forth. So it keeps telling about what are the latest promotional schemes that are available on various products in that particular retail outlet. So if the company has got, say, 3 levels of in-store promotion, one a very high level of in-store promotion, the other a medium level of in-store promotion, and the third a very low level of store promotion, or either no store promotion, the company would certainly like to know that if they do this much of store promotion, how much or whether there is any effect on sales or not. If all the three various, the hypothesis here will be that there is no effect of store promotion on sales, That means the mean sales remains the mean sales remains equal in all the three cases, whether we do a sales promotion, whether we do a moderate sales promotion, or middle or very high, or no promotion. So if this hypothesis stands true, then perhaps there is no point in spending money on sales promotion. So usually marketeers will be more than willing to know whether the sales promotion that they do really affects the sales. Commonsensical, it should appear that higher the sales promotion, higher should be the sales. But this relationship can be tested through analysis of variance, which we will do in this case. The null hypothesis, as I already mentioned, in layman terms, it means that the mean sales remains the same in all the three levels of sales promotion. So in other words, the mean sales of when there is no promotion is equal to the mean sales when there is a moderate or middle level of promotion is equal to the mean sales of when there is high level of promotion. This also the table is the data which has been entered. If you look at the table closely, you can know that we have taken 30 observations, serial numbered 1 to 30. The second column represents the coupon level. So coupons are also given. If you are a marketeer, or if you are aware, then you know that many of these marketeers give you coupons. And when you go to the stores with the coupons that they have given, they give you some discount, additional discount on the coupons, which is called as redemption of coupons. The biggest problem with these coupons is that very small percentage of coupons actually get redeemed. Maybe only say 5% coupons get redeemed. So people, even after looking at the coupons, they usually don't have the inclination, or they don't go to the stores. So there are two levels of coupon. One where there is no coupon given to the shop consumers or shoppers, and in the second level there may be coupon may be given. So we also may be interested in looking what happens when coupon is given as compared to what happens when the coupon is not given. However, our major area of concern is the in-stores promotion. When the consumer is in the store, then the stores do some kind of a promotion, like I said, high level of promotion and medium and low level of promotion, and which is indicated by 1, 2 or 3. Then we are interested in knowing whether the mean sales when it is high level or medium level or low level, whether the sales is different. We can go back to the previous example, and I can give you an example of which test will be eligible in which scenario, because we have already discussed this thing in the beginning, that what is the relationship between various types of variables. So if you take coupon level as the independent variable and sales as the dependent variable, basically we want to know whether if we give coupon or if we don't give coupon, whether the sales are same or different. Then independent variable is categorical, only two categories are there, either coupon is there or coupon is not there, and the dependent variable is sales, which is metric ratio variable. So in this case, when the independent variable is binary and the dependent variable is metric, we use what is called as independent sample t-test. In the same scenario, if we are comparing whether the in-store promotion affects sales, but the in-store promotion is a categorical independent variable, sales is a dependent metric variable, but in this case the in-store promotion has got three categories, 1, 2 and 3. One where perhaps there is very large very high sales promotion is there, 2 when there is medium, and 3 when there is no sales promotion. So since there are now 3 categories in the independent variable, we will use what is called as ANOVA, which is our topic of discussion today. However, if in the same case we wanted to test both the effect of coupon level as well as the in-store promotion together, then we can do what is called as two-way analysis of variance, because there are two independent variables, both categorical in nature. So then it becomes two-way analysis of variance. Again, if we wanted to see, there is again another metric variable which is called as clientele rating. Clientele rating is the shoppers which are coming to the store may also not be same. Some may be knowing the store very well. They may have a lot of familiarity or loyalty towards the store. Some may be little lower in loyalty. So if we are measuring, say, loyalty or something of the clients and then rating them accordingly on perhaps a scale of 0 to 10, then client rating also becomes an interval metric variable. Now, if in the same case we also wanted to know coupon level, in-store promotion and client rating effect on sales. So sales becomes a dependent variable and these three become independent variable, and we want to see the effect. We have to then apply what is called as analysis of covariance, simply because clientele rating, which is an independent variable, which we are assuming as an independent variable here, is also a metric variable. So when there is metric variable and non-metric, both types of variables as independent variable, we can only use what is called as analysis of covariance. However, if we wanted to know only the relationship between clientele rating and sales, then these two variables both are metric variables, and both metric variables can be compared using what is called as correlation and regression. So whatever we discussed, looking at this table, we can know which technique will be used in which circumstance, and in this case we will be using one-way analysis of variance, trying to know the effect of in-store promotion on sales. So if you look at it, you will find that there are three levels of in-store promotion. There is a high level, there is a medium level, and there is a low level of sales promotion, and we have taken 10 in each of the categories, 10 observations in each of the categories from 10 different respondents. When there is high level of sales, high level of in-store promotion, the sales that we get is 10, 9, 10, 8, 9, etc., etc. When there is medium level of store promotion, we got sales 8, 8, 7, 9, 6, etc. And when there is low level of store promotion, we find the sales to be 5, 7, 6, 4, etc., etc. If we take the total of it and find the mean, we find that the mean sales when there is high level of promotion is 8.3, the mean sales when there is medium promotion is 6.2, and the mean sales when the in-store promotion is low is only 3.7. Looking at this descriptive statistics, we can say with a little bit of intuition and little bit of analysis that perhaps the in-store promotion affects sales, because as we go from low to high level of in-store promotion, the mean sale value increases from 3.7 to 6.2 to 8.3. Our hypothesis in this analysis of variance is that the mean is equal. That is, can we consider 8.3, 6.2 and 3.7 to be equal, and then equal to the group mean, which is, or the total mean, which is actually 6.067. So the hypothesis stated in this case is 8.3 is equal to 6.2 is equal to 3.7 is equal to 6.067. If I look at the figure, it might appear that this hypothesis might get rejected, because the three means seem to be very different, especially 8.3 and 3.7 don't seem to be looking close to each other. So the hypothesis may actually get rejected, but we will have to actually apply hypothesis testing and see whether the hypothesis gets rejected. But descriptive gives us some idea about our commonsensical interpretation of the situation. Now this shows the methodology in which we are going. So first we are finding out the sum of squares or the deviation, squared deviations of all the values. So this is the entire variation in sales. So if we take all the 30 values, that is of all the groups taken together, if we take all the values and then subtract them from the overall mean, which is 6.067, and square them, this is the overall variation, which is denoted by SSY. This comes out to be 185.867. Now, as we said that this variation, this total variation is because of the variation within the group, which is the variation within when the 10 values of high promotion, the variation between the 10 values of medium, and the variation between the 10 values of low promotion. So this is the result of within group variation as well as across group variation. So if we add these two variations, we will get what is called as total variation, which we have just now calculated as SSY. Now SSY is equal to SSX plus SS error. SSX is the variation between the groups, which is so we find out that the first group mean is 8.3. We subtract 6.067, which is the overall mean from the group mean, and since there are 10 values, we multiply it with 10, and similarly we get SSX equal to 106.067. SS error, on the other hand, is found out by subtracting the category mean from the various values of that category. So for the first category, the mean is 8.3. So we are subtracting 10, 9, etc. We are subtracting 8.3 from the various values of the first group. This is the first group. If you see, the various values are 10, 9, 10. So if we start subtracting 8.3 from 10, 9, 10, etc., we will get what is the SS error. Similarly, we have to do it for the other groups also. The group which has got a mean of 6.2 and the third group which has got a mean of 3.7, and then find out the squares of these and add all of them together. Adding all of them together gives us SS error to be 79.80. And as we define the relationship that SSY is equal to SSX plus SS error, we can actually test this hypothesis, and we can actually know that 185 is equal to SSX plus SS error. Now the F value comes out to be 17.944. When we look at the table, we found out that the F value for 2 and 27 degrees of freedom, the critical value is 3.35, and this value comes out to be very much higher than the critical value. 17.944 is very much higher than 3.35. So we are bound to reject the null hypothesis. So we have to conclude that the three group means are not equal, and the in-store promotion actually affects the sales. As we have seen from the descriptive, as we have seen from the commonsensical interpretation of descriptive, that the three means seems to be different, it actually comes out in hypothesis testing that the three means are actually different. However, when the hypothesis gets rejected, we are not sure whether the first one is different from the second, third, or the second is different from first, third, or all three of them are different. So there are various possibilities which may occur, for which we may require to do testing of two at a time by independent sample t-test. So this is the output that we get from SPSS. If you are using software tool like SPSS, this is the output that we get, and you see that F ratio in this comes out to be 17.944. If I were to explain, then between group sum of squares 106.067, it is the same as we calculated, and we showed the how it got how did we calculate that. Within groups comes out to be 79.8, and overall SSY comes out to be 185.86, which we calculated, and the sum of squares added gives total sum of squares. Then degree of freedom is 2 and 27. When we divide the sum of squares from degrees of freedom, we get what is mean square. So mean square 53.033 comes out from 106.067 divided by 2. Then the mean square of between groups and the mean square of within groups are divided to give the F ratio, which is 17.944, and then we compare it, and the F value comes, the p value comes out to be equal to 0.000, so we reject the null hypothesis of all means being equal, because the p value comes out to be less than 0.05. In this case it is almost equal to 0. And these are the group means, which give us an indication that high level of promotion results into high sales, and low level of promotion results into low sales. What are the various assumptions? The assumptions are that categories are independent variables are fixed. This is called as fixed effects. The error term is normally distributed. The error terms are uncorrelated. And similarly, we can do n-way analysis of variance, because as I told you, if we wanted to see the level of the coupon level as well as the effect of in-store promotion together, then we will have to apply what is called as n-way analysis of variance. Currently, I am not going to do it. However, this gives you an idea that two-way analysis of variance can be conducted in if we have got two independent variables. What are the various issues in interpretation? When we are interpreting the outputs, we have to be sure that there should not be any interaction. If we are doing a two-way or n-way analysis of variance, there should not be interaction effects. And these are various other issues. We have already talked about omega squared. This tells us how much is the variation explained. It is similar to eta square in the interpretation. If we are doing it with SPSS, these are the commands that we need to follow. We have to go to analyze, we have to go to compare means, then one-way analysis of variance, and then we can apply one-way analysis of variance. We have to put the dependent variable, which is the metric variable, into the dependent box, and the independent variable in the factor box. So these are the steps in the SPSS windows. However, we will also try to attempt it through Excel. This can be done in Excel also, and I am using the same data that we used for this same example is being taken. The third column that you see is the coupon level, 1 being very high level, 2 being medium, and 3 being lower level, and these are the sales. However, when we are in Excel, we have to put data in either rows or columns. So I am currently trying to put data in rows and columns of all 1 together. So this H column is all the various level of sales when the coupon when the sales promotion is very high. Then the second column is when the sales promotion is medium. This is the sales when the sales promotion is medium, and the third one is when the sales promotion is almost negligible. So the sales is this when the sales promotion is almost negligible. Now I have put in the data. So these are the 3 columns. The first column is the sales of high sales promotion, second medium, and the third one is low sales promotion. In Excel, we have to go to data. We can go to data analysis, and we can select one-way ANOVA. This is the kind of output, this is the kind of dialog box that you will get, and here you will have to give the input range. So we will go and select all the 3 columns from the first one to the last cell and select it as the input range. Now we have to tell whether we want to compare the groups and whether the groups are entered column wise. So here we say that the first column is the in-store promotion when it is high, and so it is the data is arranged in columns. However, we could have arranged the data in rows and then we would have selected rows. but column is the default value which we can take here as the same, and now we can go and say OK. This is the output that we are going to get of ANOVA. This is the output that we are going to get in ANOVA in Excel. The column 1 represents the count and the average. The average comes out to be 8.3, 6.2 and 3.7 as we have found out in the example. And if you see the output, the output is similar. The SS between groups is 106.7, 79.8 and total variation is the same. The F value is also the same, 17.94, and the P value comes out to be very less, it is almost 0.000, and critical value is also given. So if you look at the critical value, it is very less than the F calculated. So we have to reject the null hypothesis and we have to conclude what we actually concluded in the SPSS outputs also. So the same analysis of variance can be conducted either using SPSS output or by using we can use either Excel also. In Excel, I will again repeat the command. We will have to go to data. We'll have to go to data. Then from data, please show the screen. From data, we will have to go to data analysis. Please ask them to show the screen, please. Then we have to go to data analysis. So when we go to data analysis, this is the dialog box that appears. We have to select ANOVA single factor because we are using only one-way analysis of variance. However, if we had two-way analysis of variance, we would have selected two-factor with replication or without replication. So we will select one-way analysis of variance and we'll say OK. This is the dialog box that appears. It will ask for the input range. So we will have to select this, and from the first cell we have to select till the last cell. Then it will ask for whether the groups are by column or by rows. As I mentioned here, the groups are column wise. The first column representing the high level of sales promotion, the second medium and the third low level of sales promotion. So we'll have to keep the column default tab as it is. Otherwise, if the data would have been entered row wise, then we would have selected rows, and then we will have to say OK. The output will first indicate the descriptive, how much is the mean of all the three groups. As we see that the mean of mean sales is very high when there is high sales promotion, and the sales is low when there is low sales promotion. So we have to we get an idea from here whether the hypothesis will get rejected or not, and when we actually look at the hypothesis, we get the F value as 17.94 and the critical value to be 3.35. So we have to reject the null hypothesis that all means are equal and conclude that at least one mean is different, or in other words, sales promotion affects sales. So this is how analysis of variance is conducted in by using Excel or SPSS. So this was all from my side in analysis of variance. Thank you very much.
So, sir, you talked about when we want to compare two things. In that case, we use the ANOVA.
When we are comparing two things, we can even use independent sample t-test. But when we are comparing more than two groups, then we cannot apply independent sample t-test. Then we have to actually apply analysis of variance. Like here, there were three groups. One group where we were having very high sales promotion, one group where we were having a medium sales promotion, and the third where we had no sales promotion. And we are looking at the sales when in the three groups.
Okay. So, if, one question I would like to ask you.
Yep.
When a student do this ANOVA test, what are the chances to come, you say data misrepresentatives can say some error that can occur which way, where they can have some precaution?
Okay, I have already said that when we are doing analysis of variance, there are various assumptions that have to be taken care of. The first and the foremost is when should ANOVA be used. ANOVA can be used in one circumstance only, when the dependent variable is metric and the independent variable is categorical. If this condition is not met, then analysis of variance cannot be applied. A lot of
Categorical, how exactly will define categorical?
categorical variable means where the categories where the number is only representing categories. For example, in our case, there were 3 categories represented by 1, 1, 2, 2, 3, 3.
Okay.
Say for example, we are comparing say salaries of the 3 classes of employees, say middle management, higher management and lower management. So the category is what will define whether the person is middle management, lower management or higher management. So if it is, we can give 1 to higher management, 2 to lower management and 3 to say middle management. So here the categorical variable is is defines the categories which we are comparing, the groups which we are comparing.
So well friends, Dr. S.K. Pandey in details talk about the ANOVA and also try to make us clear through different examples and different illustrations. So I hope this lecture must be beneficial for all of you. And with this word, we would like to conclude the lecture. I thank all of you for watching the lecture, and on your behalf, I thank Dr. S.K. Pandey for giving such a wonderful lecture. Thank you very much.